Perhaps the greatest achievement of modern man is the ability to harness the power of Zeus. The importance of controlling electricity is easy to take for granted, but electricity is why doing stuff at night is so easy, and at this point, it's what keeps the first world first. But what should be the second greatest achievement of the industrialized world gets even less attention. It's the ability to put Zeus in your pocket. The battery is the silent, unsung hero of modern man, and batteries are everywhere. Just go to a concert. The ability to store up some energy, walk around with it, and use it when you need it has had a profound effect on our lives and our cultures. The battery is what gives us instant images, and that has made things possible like internet memes and revolutions. There are many different types of batteries, but they all pretty much work the same. Let's look at a cell phone battery. Now, to understand how a rechargeable battery works, you need to know a little background.
The electron.
This is an atom. The inside has a clump of positive charged particles in it called protons. The outside is a buzzing cloud of negatively charged particles called electrons. And electrons are the key to electricity. The movement of electrons is what makes the lights go on. So how do you get electrons to move through a wire if they're happy just buzzing around as part of an atom? Well, it turns out that electrons just want to be happy. And for electrons, happiness is being at a lower energy level. Think of it like this. Let's say a high energy level is like working at a high stress job, and a low energy level is like sitting at home stress-free. If your boss said, "Hey, do you want to work from home?" you'd do that. And if your boss said, "Hey, do you want to stay at home and still get paid for not doing work?" who wouldn't do that? Well, electrons do the same thing. For electrons, buzzing around some atoms is like working in a high-stress environment, and buzzing around others is like sitting at home and getting paid for nothing. A battery basically gives electrons a path to a happy, stress-free life, but makes them work for it, which we'll get to in a second.
The ion.
Here's the atom again. As we mentioned earlier, there's a positive charge part and a negative charge part. In a normal atom, there's balance. The number of protons equals the number of electrons. But if an electron leaves this atom, now the positives outweigh the negatives, and we're left with a net positive charge. Add electrons, and we're left with a net negative charge. These are ions. An ion is simply an atom that is no longer neutral. It has a charge because it has either lost or gained electrons. So while electrons want a low energy, stress-free life to be happy, ions just want to be neutral. And they do this by finding an opposite charge and sticking together. The heart of a battery is electrons and ions trying to achieve happiness.
The battery.
Let's look at what parts make up a generic rechargeable battery. First, you need two different materials. One that for an electron is like working 80 hours a week for an abusive boss, high energy level, and the other is like sitting at home collecting paychecks, low energy level. In other words, given the option, an electron in material A would rather be in material B. In fact, if you just put these two materials together, electrons would just hop from one to the other. They would take a shortcut. To stop electrons from taking the shortcut, you need to add a barrier that forces them to take a detour. This detour is the circuit. In other words, the thing you're powering with the battery. And finally, you need something for ions to move around in. Here's how it works. With the circuit off, electrons in material A are stuck in their high energy, high stress atoms. Out of reach and on the other side of this electron barrier are material B atoms, which would offer an easy, cushy, low energy level position. Let's turn the circuit on. Now you've offered electrons a path to happiness. Since they can't go any other way, they begin flowing through the circuit to material B. Back at material A, the atoms are losing electrons, because that's where the electrons are coming from, and they begin turning into positively charged ions. As we mentioned before, ions always want to be neutral, so these guys need to find a negative charge. So they go to where the negative charges are, in material B, where all the electrons are going. You'd think that these ions would just meet up with their lost electrons and become neutral atoms again. But unfortunately, the electrons are way happier where they are now, so the ions have no choice but to kind of mingle with the atoms of material B. So what we've got is kind of a mishmash with B atoms mingled with A ions. As the battery discharges, electrons and ions are making their way from A to B. When you can't fit any more material A ions into material B, the battery is fully discharged. To recharge the battery, you just do things in reverse. Instead of a circuit, you're putting in energy that forces the electrons back into material A. The ions then leave material B and rejoin their lost electrons, and the battery is ready to discharge again.